Okay, artists. So if you're watching this video, this is a bit of an advanced breakdown of some of the nuances of two-point perspective. If you haven't watched video 1, where you've perhaps missed class or feel like you could use a review before you get into this, check out the first video. It's pretty short. It's under 10 minutes, a little over 9, and it covers when you use perspective, 2-point specifically, and how you break it down. All right? So now let's get into slightly more complex shapes. You might have a myriad of different objects that you're going to be creating using 2-point perspective, and this can't answer all your questions, but it can give you a baseline understanding of the logic and problem-solving skills you want to know no matter what you're tackling. Otherwise, if you've got something a little more complex, if you've got something that you can't quite suss out, the logic just eludes you, feel free to ask for some help. So, presuming that you understand the basics of 2-point, now let's get into some more challenging shapes. For example, we went over a lot of boxes. The idea is that you carve away more complex shapes from simple ones. You create a cylinder, a box, and you cut away or add to it. So in this case, let's try a cylinder, right? Using 2-point perspective. Now remember, we think in terms of a corner facing us, being the nearest part of an object with 2 planes running into separate directions. The parallel lines to the right of that corner go to the right vanishing point, and those running to the left go to the left vanishing point, right? And then any lines parallel to them go to the corresponding, the same vanishing point. So this partner goes here, this partner goes here, right? But remember, this is for objects that have corners. So if you're trying to create a cylinder, your logic might be, well, there is no part that's nearest me. There is no edge sticking out with 2 planes going away. That's true. But you can still use the 2-point perspective to help guide the angles, to try to capture the accurate vantage point that you're seeing a cylinder at. Rather than have to estimate, you can use this to inform you. So let's thin this out a bit to create a more symmetrical, kind of consistent polygon here. Now notice how this works. Creating a cylinder means I know that my cylinder is going to be rather warped because I'm seeing it from below, and I can use this sort of the guidelines of my polygon, my rectangle, to guide me, because this is how you use it. When you create rectangles, or a square, you mark the halfway point. Let's do a little x-ray. Here, 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 here. You're marking the halfway point of each line, right? So this is half the length, half the length, half the length. And then you connect the dots with a circle, right? And then you shave away the excess. And the logic there is that no matter what perspective you're looking at, no matter how skewed or warped like an object might be, because of the perspective, the viewpoint you're getting, this little trick will help warp it correctly for you so it takes guesswork out of the equation. So take a look. I'm connecting the dots, bringing those lines up, right? And that would be the odd vantage point I'm seeing my cylinder like so. Make sense? So let's try the logic of a pyramid. So we start with, remember, to create a polygon, that corner. But our corners are going to be a little skew with the pyramid, right? Because the edges kind of taper upwards. So instead of doing the entire object, we can just do the base. So consider making a square instead, right? This is sort of like our unseen corner, right? Well, the lines to the left of our little point, our edge, go to the left vanishing point. To the right, they go to our right vanishing point, right? But now, if we're making a square, its partner, opposite this guy, well, he's parallel to him, so he's going to also go to the left vanishing point. And opposite this guy, our other parallel partner will report to the right vanishing point, right? So I don't need these lines anymore. But what I could use is a reminder that a pyramid has lines running up from the base that taper into a point, right? And that point is centered. So let me just make an X. Again, no guesswork. That's my center, right? So I just move a line up from that center. And now let's rise to meet it. From each corner, bam, 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 right? Now let's just darken it. It can be weird to consider just how two-point perspective affects all objects. So you might not always have the answers. You might not always instinctually be able to jump right into drafting it on the page. But what we're hopefully doing right now is sort of giving you some logic to it, some reminders how you would tackle different challenges if you're considering those 2 points on the horizon line and the fact that all parallel lines running away from you are reporting there. Each object might be affected a little differently by that formula. So let's try something else, a little more complex. Say like, let's consider a car. All right? Now, I'm terrible at drawing cars. You are likely far better than I, even thumbnailing it. But take a look at the logic here. If a car is parked askew, right? If like say one tire is closer to us than the rest, we're seeing a corner facing us, right? Here's the logic. I'm creating the base once more with parallel lines running away from me to that vanishing point. And there's the base of my car, right? So if I was to create a bit of width, a bit of height to that thing, well, notice my parallel lines all reporting that same vanishing point. Because this line is to the right of the corner and parallel with its partner here. Again, both going to the same one. All right, now I could create wheels. I'm creating cylinders then. So follow that logic. And then here, parallel curve right here. Again, more wheels, parallel with its partners, so they're reporting the same vanishing point. Those horizontal lines are. Here's our awkward car so far. Now, I'm going to start carving away to make it more complex. Say the hood of the car is maybe yay thick with a bumper. That bumper is parallel to the wheels, the frame of the car. It's reporting the same vanishing point. Hood of the car. God, I can't draw cars to save my life, I'm realizing. This guy is going to be awkward. Parallel shape. Now let's make some windows. Their bottoms being parallel to the ground. The windshield being parallel to the roof of the car. And the hood reporting that same vanishing point. Again, any horizontal line running away from me is going to go to one of those two vanishing points. So I simply look at the lines I've already laid down to kind of help guide me. Let's put a license plate on there. Even wheel wells will line up. You can see how I'm kind of using a template to guide me here with how high or low they rise up. Definitely not my best work, but you can see the logic being employed. The consistency. Right? So consider when you're breaking down more complex shapes, always start with a simple one and then try to follow that logic. If ever you don't know what to do, consider which lines report to which vanishing points, which lines are parallel with one another, because that will guide you to the correct vanishing point. And always start with the simple shapes and carve away or add on to create increasingly more complex ones. If you get stuck, don't hesitate at all to ask questions. Hopefully this video has provided a bit of insight, but there's also plenty on YouTube and online too that break down far more complex things like robots, toys, the drafting of 3D products, automobiles that are far better than this, architecture. So you can always check out other artists too doing a bit of a deeper dive and spending a little more time on it than I am for the purpose of these shorter intro videos. Feel free to do a little research yourself too if you'd like to hear it explained by another artist. Ask myself in class. But what I'm going to suggest you do above all, never freeze up. If you don't understand how to do something, do it to the best of your abilities, to the closest approximation you think how it works. Then we'll take a look at it and we'll be able to spot the snags where we went wrong and help you to refine your process and boost your confidence. That's much harder to do if one simply shuts down when they're approaching something they don't understand. Try to work your way through it logically. Then we'll take a look and see if we can refine and improve from there. Okay? Excellent. Okay? Whew, that wheel is sticking out weirdly. All right. So, let's see what you got in class. Take a look at your work, and best of luck.